Test Safety Workshop. Without further ado, I'd like to introduce the afternoon session chair, Mr. Steve Wright. He is another distinguished graduate of the United States Naval Academy. He's got a master's in aero engineering from post-grad school out in Monterey, which I hear is really, really arduous duty. He did 24 years in the Navy. He's a P3 driver by trade. Graduated from U.S. Naval TPS class number 101. Somehow he lucked into 5 flying tours at PAX, which I'm not sure how anybody could get 5 flying tours anywhere, and 5 at PAX sounds pretty fantastic. He was an instructor at the school, commanded VX-20, I think it was still called VX-20 at that point. And now he's the chief pilot for KBR Wiley. He's got over 5,000 hours and 65 different type model series aircraft.
Good afternoon, everybody. It's a pleasure to be here today at the Flight Test Safety Workshop, serving as a session chairman. I had the good fortune of doing this also last year at Melbourne, and I really like this forum. I love the opportunity to share lessons among representatives for different companies, domestically, internationally, those kinds of things. It's just a great forum to be able to do that, and I think this workshop this year has been no exception, and I'm sure it will continue. So the last speaker that we had was Turbo, of course, and Turbo told us that he was not a very good singer, a very good dancer, and not a very good drawer or artist. But I was at Anaheim last year, and I did see him sing and dance, and he actually did a pretty darn good job, and his drawing today I thought was pretty good as well. So I can assure you I'm not going to sing or dance. I'm not wearing a Batman or Superman shirt or anything like that. And I'd even suggest that I'm going to thank Turbo. Where are you, Turbo, anyway? Raise your hand. Are you still here, or did you ditch? He's out. But, you know, on Turbo's scale, he had that knowledge versus skill or knowledge versus stupidity metric when he was trying to talk about his human quality rating. And even though he's not here, I'm going to thank Turbo for not using stupidity on that scale, because he also had something about left-right. You know, do you have the left stuff? Do you have the right stuff? And by virtue of my last name being Wright, I'd really like to be able to say, but I can't, that I have the right stuff, because I've spent my entire life misspelling my name. It's a W instead of an R, so it just doesn't work. Anyway, it's apparent that the lessons learned from the past keep repeating themselves, and I think it's really important that we don't lose sight of those lessons learned, even as technology advances and we push the envelope with fly-by-wire systems and aircraft instead of airplanes or rotorcraft and those kinds of things. We still have to keep those lessons from the past in our focus. And there's a lot of folks here, Jerry White's is among them, there's many others who have been longtime participants in this forum and other forums, who have heard those kinds of lessons learned and applied them to test teams and shared them with the newer faces. Also at this workshop, there are those newer faces. Perhaps there's, just show of hands, how many people are here for the Flight Test Safety Workshop for the very first time? Show of hands. There's a lot of hands up there, almost half, maybe 2/5 or so. So my challenge to you as a representative of the Flight Test Safety Committee as well is to A, continue coming to these kinds of forums, and to be an active participant in spreading the word, if you will, in your organizations, in the test teams and engineering disciplines that you're involved in, because it's really important that we do this. Things that struck me during the course of the last several technical sessions, I heard things like, when the impossible happens, are you going to be ready? Are we really thinking about what might happen or what could happen? And I don't know about you, but I remember way back in TPS, back in the early 90s, when somebody said, that can't happen or it will never happen, the hair on the back of your neck should be standing up right away, because those things do happen, and they happen a lot. Smells is a Kevin Gross who gave the presentation about the ship and the missile. You know, it's alarming that stuff like that can happen. How do we respond in time-critical situations? How do we risk mitigate and incorporate daily ORM into our test hazard analysis for the test, as well as for that crew with that weather on that air vehicle with that maintenance history on that day? It all plays into the overall level of success or failure for that day. Somebody said, I think it was the Auto GCAS folks, planting seeds in an informal forum like this can help to run a parallel course to perhaps incorporate new technology in an informal way, or to get inertia going in an informal way rather than just lying on the formal bureaucracy. So these forums are important for that as well. Rehearsal, simulation not necessarily being representative of flight test and vice versa. These are all things that we've heard before. How about this one, the whole team approach? Individual preparation. You go to school, you get an education, maybe you go to test pilot school, or you learn from somebody else, and you do everything that you can do to be the best person that you can be. But who's watching out for the whole team? It's not just the pilots, it's not just the air crew in the back if you're in a multi-place aircraft. How about the monitoring engineers and the test conductor and the training for all those different things? Somebody's got to be paying attention to all that stuff. And lastly, small changes, like in the steep approach presentation we had. Small changes can result in big changes in the overall outcome. So there's a lot of lessons that we need to continue to pay attention to. And I'm going to be here today just to help facilitate and get these speakers out so that you can hear about what they've got to present. Our first speaker today is Lieutenant Colonel Tom Fields. He tells me his real name is Dale, but he goes by Tom. There's probably a story there. He's a Marine. He's currently the government flight test director for the F-35 at VX-23 down at Pax River. He's got a BS in aerospace engineering from Virginia Tech. He's been all over the world. He was commissioned, I guess, in 1998. Yep. Designated as an aviator in 2000. He did his initial training in F-18 Hornets, served in Iwakuni with VMFA 212. He went on to Camp Lejeune and the 24th Marine Expeditionary Unit, deployed overseas to sandy, dusty places there. He also went to Oceania, served with the FRS, VFA 106, for the F-18 FRS there in Oceania. Let's see, he's been to Edwards, the Air Force Test Pilot School. He's been to China Lake with the VX-31 Dust Devils. He's been to Beaufort. And now he's at Pax River with VX-23, as I said, as a government flight test director and formerly as the operations officer. Let's see, he's a graduate of Top Gun. He's got over 2,500 flight hours and 30 aircraft, and he is a member of SETP. And he is going to talk to us today about flight test continuation criteria, lessons learned in the F-35 flight test program. Please welcome Tom Fields.
Thanks for the introduction. Good news, bad news story. We all just shoved a bunch of food in our faces and now it's sitting down in our stomach. And man, that tasted good. But bad news is the coma is going to hit soon. So I come prepared. First guy who gets tired, raise your hand. I'll run this out to you. And we'll keep going through. For the rest of us, we're going to have to power through Marine style and see what we can do. All right, so I'm really here just to share a couple events that we've seen in the last 12 months in F-35 test in Pax River that have really changed the way that I'll approach flight test continuation criteria, and hopefully in the process you guys will get something to walk away with. Okay, so flight test continuation criteria, what are we talking about? This is not a novel idea, but I've personally called it something different in the past, but we're really using or developing tools to use an envelope expansion. So identifying safety of flight parameters and using predictions and test background and test history to line up tolerances that are going to keep us within thresholds. So if you hit a threshold, you may be entering into a safety of flight or a danger area. And then if you hit those tolerances, establishing a get well plan, whether we continue the flight test today or we stop and we come back again another day. Down at the Integrated Test Force in Pax River, our approach is our FQ team owns these criteria. They establish them, we reference them in our test plans. Some good examples of quantitative tolerances that we're going to look to. You know, where your CG is, what our control margin is for the day, air data quality, hinge moments for loads, tail temperatures if you're going after high-speed testing. You're going to be an afterburner for a long time. And then you get into more squishy areas like handling qualities, system evals, Handling qualities, we're going to add in handling quality ratings of 5 or greater, PIO ratings of 3 or greater. And again, recognizing that those are going to come at different ratings from different pilots under different days. System evals. So we don't have hard criteria in our flight test continuation criteria for system evals, but we do reference workload, system integrity, system performance to identify when we're reaching a tolerance. So specifically, we'll talk to air-to-air fueling with the KC-135 boom drogue assembly. For those of us in naval aviation, also known as the Iron Maiden. And we're looking to expand the envelope to be able to use the afterburner on the F-35 to be able to go higher and heavier and slower. We'll also talk to some night system evals we did on LHA USS America last November. So on our 3rd developmental test period at sea, looking to clear the aircraft for aided takeoffs and landings with the Gen 3 helmet. All right, first we'll start talking with the air-to-air fueling. We'll talk to our systems, the systems under test, task description, and then some of our safety considerations and our game plan. And then we'll watch some videos of our testing. So system, to be first from the KC-135 perspective, for those of us that are unfamiliar, they basically modified the boom, centerline boom for a KC-135 by placing a large metal knuckle right here, attaching a huge hose to it, about 9 feet long, think fire hose type of material. Another knuckle here where you attach a heavy basket to. A lot of rubber and a lot of weight right there. So 3 things that have a lot of weight to them, 1 short hose, and a lot of things to bang your canopy, air data system, and lose a probe on, or maybe introduce some extra ingredients into your engine there. For the additional consideration, this picture is taken from the boom operator's perspective. They're flying the boom while you're trying to plug in it. This works great for heavier aircraft where they've got to move the boom around. They're flying it using a stick, a controller, and then these control surfaces move that boom left and right, up and down. From the F-35, we'll talk more specifically to the system in a second. And the tasks that we're really looking to accomplish, pretty straightforward. Come in, do a wake survey at each condition behind the basket itself, assess pre-contact conditions, so you're just short of getting ready to plug, and then assess the task of plugging and then maintaining the fuel transfer zone. You'll do that straight and level, then to 15 degrees angle of bank, then 30 degrees angle of bank, and in both directions. So, a couple things to consider from the F-35 perspective: placement of the refueling probe. Just off the right side of the nose, which is pretty standard. What's not necessarily standard is that what's directly between the eyesight of the pilot and the probe itself is a canopy bow. So it's perfectly placed so you can't see the probe without moving your head. And then the relative position of the probe to the pilot's vision produces some challenges in terms of assessing where the probe is and then predicting where it's going to go based on your current inputs. Additionally, we're planning to use afterburner in these tests. So the standard throttle configuration is you have at the mill detent, you have resistance on the throttle, you push forward, up and through that, and then you're in a burner and you feel a little kick in the seat of the pants. Just for your awareness, there's about 4 stages of afterburner in the F-35. No indication to you in the cockpit of what stage you're in, but seat of the pants feel and combined with movement on the throttle, and you have a pretty good feel for when you're hitting a new stage of afterburner. So what we'll do is look at a quick video here, and this is just a plug on a KC-135, but on a long hose off one of the wingtip pods. But what we can see is a perspective from the pilot, and then you can look at closure rates and then movement of the pilot's head as we get close to plugging. So real quick, HMD display, as you look forward, it stabilizes, so it presents to you a similar picture like a HUD would. Off the left side, you've got airspeed, on the right side, altitude, flight path marker, velocity vector, depending on what language you speak, and then XL, decel Q, and some other references for us. Here we go. Be aware this picture itself is a little skewed in terms of the helmet camera is about 3 to 4 inches above eyesight. So it's looking right at the canopy bow the whole time, but this will come in discussions later. Okay, so good news, no drama there, but very nice controlled approach, good handling, good flying qualities of the aircraft in the air-to-air refueling arena. So concerns we had during this test as we approached the test, obviously we're concerned about lag in our fore aft control with selecting afterburner coming in and out of it under different conditions, in and out of turns, and then we're also concerned about at slower speeds and higher altitude, control deflections exceeding that 9-foot hose and putting us in a position where we may damage our aircraft, the tanker, or possibly something worse. So we're stuck with our generic game plan, our established plan of using HQRs, PIO ratings to let us know when it's time to take a break from test. But we also added in pre-contact evaluations for each condition prior to continuing. The intent was, let's identify from pre-contact if it's possible to even tanking under these conditions, straight and level in a turn and in both directions. And then that way, if we don't perceive it, it is possible to do, and that's an edge of the envelope, and we'll come back and assess that later. So it seems like at the time we felt like we had a pretty good game plan. Let's look at our second flight test with the afterburner. We got an F-35C here, fully loaded air-to-ground gun pod and bombs and weapons across the wings. Okay, you can see he's working kind of hard there, just as someone who's done it, you're sweating pretty heavily when you're right there behind the Iron Maiden itself. So another feature that I hadn't mentioned yet, as we started this day of flight test, our second flight test, the KC-135 autopilot failed, and we had to make a decision: do we continue without the autopilot? And we said, of course. I mean, why would you want to limit the envelope to autopilot only? Now, I've flown a KC-135 once and was heavily coached and ended the flight very sweaty and frustrated. So I can only imagine what these guys were like. But as a point of reference, the tanker pilots were fatigued, ran out of energy before the test pilots did. And we had to stop testing this day due to tanker pilot fatigue. So we're going to continue this. Something to take a look at as we continue the video is the horizontal stabs, and then hopefully you'll be able to hear the comm at the end of it.
Continue transfer standby. Is there any reason to continue control?
So I don't know if you could hear that or not, but the test pilot eventually came up and said, do you guys see any reason to continue control? And I think they came back and said no. But an interesting point there, he had reached control saturation. So as he's moving the stick fore aft, the controls cannot keep up with his inputs. And so we've reached a corner there. But no one said anything from the control room, and the pilot didn't say anything either until he stopped sweating for a second. So we obviously have reached a corner, and our continuation criteria game plan has failed us. Let's look for our final test event with the KC-135. This is another endpoint, and we declare testing complete after this. So we'll watch that one more time, but something to consider to take a look at is there was interesting interaction there between the boom operator and the test aircraft. The test aircraft makes a maneuver that's a little uncomfortable in terms of the hose is between the basket and the canopy. And then the boom operator makes what was probably a smart maneuver to assist in fixing that situation. And as the test bot corrects, the knuckle where the boom meets the hose comes fairly close to his canopy. And then the boom operator's had enough, pulls away, breaks the probe tip off. And the probe tip fails as designed, no FOD ingested in the engine, but we've reached an endpoint. So obviously our FTCC game plan has not had the desired results. The good news is we had seen enough of the envelope that we felt like we had something very useful for the fleet, and there wasn't a need to return to a test here. Okay, so moving on to our evaluation on the ship. We'll talk to the system and task description very shortly. The system itself that we're worried about is the helmet, and we've got a decent breakdown of that in the next slide. The flying qualities of the F-35 had fairly comfortable with those at the ship. This was our third trip and developmental test to the ship, and this was also simultaneously the second trip for operational test in the F-35. So the performance of the aircraft in the STOVL environment is fairly established, and we're comfortable with its ability to take off and land during day and night conditions, unaided. The task for the night is very straightforward. Execute a deck eval of the lighting on the ship, and then once, if the aircrew is comfortable, execute a short takeoff, execute multiple low approaches until you've reached a fuel state which we can hover, and then decel to a hover and a vertical landing. So for the Gen 3 helmet, this is just for our generic essay, it's designed to be one-stop shopping. In one helmet, I have off-bore sight capability. I have HMD that provides a light display when facing forward. And as the conditions change outside, I don't have to take off my visor and put on AMBUS 9 NVGs to have night vision capability. We've got two cameras that assist in that. There's a camera on the dash forward of the pilot, and there's a camera on your helmet. This camera forward of the pilot is designed to capture a view forward of you that allows the pilot to see through the canopy itself, the canopy bow itself. And then the helmet cam is also similar capabilities, also collecting images for you, and then processing and projecting those images on the visor. So things we're worried about here: ship lighting control and adjustment. Not the simplest thing to do in the world. Most aircraft around the LHA, LHD, rotary aircraft will wear AMBUS 9s, do aided landings and takeoffs, and so you want covert lighting. And then adjusting those to overt conditions to allow for AV-8Bs to land either aided or unaided is not a simple process. Think top of the line rheostat production from 1947, and that's what you're getting in your brand new LHA USS America. Some things don't change very quickly. It would take us something along 10 knobs on those rheostats to adjust depending on lighting conditions, plus 2 more control stations to adjust the lighting on the deck in between aided and unaided landings. We're also concerned about cliffs and system performance in the helmet. The helmet had not been tested very thoroughly in terms of numbers of hours airborne, and we had seen some degradations in performance that we were concerned about. So we established a mitigation plan in our build up to the actual dead itself, and then once we're out on the ship, our mitigation plan consisted of doing unaided night landings under low light conditions and high light conditions, and then starting aided landings under high light conditions and transitioning to low light. Additionally, working from our most experienced to our least experienced pilots. One aspect of the helmet that has always been advantageous to us is HOTASable controls on what's displayed in your helmet. So if I want to turn my night vision system off, I just click right, castle right on the stick, and I'll turn it off, back to unaided display. If I want it back, I can quickly command that, and it's available to you. This has come in as a mitigating feature in air-to-air refueling at night, and also in FCLPs at the field. So let's get to the videos, and we'll talk through a couple things here. Okay, what we're looking at here is, shoot, I missed it again. Highlight conditions, very highlight conditions. As it was, this is a super moon during our det, the brightest the moon's been in 50 years. I don't know how that happens, but it did. It's really bright. And so what you're looking at forward of you, this is the image from the FCAM overlaid. It's a picture-in-picture type of presentation, and as the FCAM's field of view ceases, now you can see the canopy bow off to the right. HMD symbology is available to you in the FCAM and still available to you as you look off bore sight. Currently, a pilot's in a hover next to the ship. He's going to transition over the ship, stabilize over spot 7, and then land. And my apologies, I falsely advertised he was going to land. He did land. We cut it out of the video because it wanted to minimize time here. But you can see the image, it's pretty good. Very easy to tell where you are relative to the ship's tower and where you are relative to the tram line, the center of the landing area. Keep in mind as we look at these videos, this imagery where we record in the aircraft is a little bit better than what you see in the helmet. So the next night after that, we flew again, super moon, and transitioned into low light. And the following night, we were at low light, and it was slowly, the moon was starting to come up as we started our test. And this will pick up with the pilot has taken off. Now he's done multiple low approaches, and he's approaching the landing area from the stern. So a couple of mitigations that we added on is to do a straight-in approach over the stern of the ship instead of transitioning from just left of the ship over the landing area. It was a little bit of a simpler maneuver and more automated. So the imagery is obviously a little bit different here. And he's slowly approaching forward. You can see on the rad out, he's a little bit lower than he normally would be. Normally be like more like 40, 50 feet here. And he's looking down at the right, trying to establish where he is fore aft on the ship. That's the tower itself, where the LSO sits. And right there are 2 generators that he walked by as he walked out to his aircraft, so he knew where those were on the ship's deck. And now he's landed. I think his words after that were something along the lines of, "Control, you're going to have to give me a compelling reason to do that again." There were some other words later on that day. I do have another video here. It's going to take us right up to the end, but I think I can get through our conclusions fairly quick. These are comments, interviews with members of the control room there, and we'll get to why this is relevant. It'll be fairly
Champ got
apparent.
into the jet and started doing a startup, and once he got started up and was flipping through MVC to kind of see how it would look, he started giving us his comments on how he thought the MVC was performing. By the time he got the deck lighting set how he wanted to with Pryfly's assistance, he was comfortable with the conditions that he was stowing off in.
As the control room engineers, when we hear that, we default to pilot's comfortable, he's a test pilot, he's experienced.
So a lot of what we're paying attention to are his comments about how the night vision camera impacted his ability to do the task of flying the airplane.
As soon as he took off and the way he talked, I was like, this is not good.
There is something obscuring my HMD, was the first one I heard. I'm like, this doesn't sound like anything we've heard to date with the night testing we've done on this detachment.
It was almost like a fog for him. So, he got up and out and went up and started kind of troubleshooting that. And, at that point I became uncomfortable and I was waiting for, what do we do next?
The fact that he kept referring to it and it was a frequent thing and it wasn't something that was just like a momentary glitch. It was something that was there and it wasn't going away. I think that's when we realized that it wasn't quite what we were expecting to have happen.
This is the point where anytime I talk about it, I start getting the heebie-jeebies, hairs on the back of my neck start standing up. So once he got into the hover and had crossed over the spot, it became very clear that the picture he was working with was unsatisfactory for doing any sort of operation in the very close vicinity of the ship.
Okay, I'm going to stop it there, but you guys get the point. They knew in the control room something was not right. So how did we do that? We took a pilot, threw him out in the deep end, and he found himself in a position where he had to recover on the ship, elected to proceed. No one told him to stop it, and he made it happen. I think his words later on were, "Screw you, ship, I'm landing on you." And we got lucky. There's no way around it. We got very lucky that night. Now, part of this is many factors apply in this. One of the major ones that I walked away from is, and I think Turbo hit on this, is the same things that make you a good pilot, the I can hack it mentality, can really get in the way when you need to make decisions early on whether or not I should be continuing this test. And that plays into air-to-air fueling, definitely played into our work at the ship at night. And my dad plays a lot of golf. He likes to say it's better to be lucky than good. But in this case, we really felt like there are some things that we need to do better as an organization. So I'm guilty of it. I went out behind the tanker right after one of our younger pilots did, and I was, didn't want to say anything to him until I'd done it. And I spent a good 5 minutes in pre-contact, sweating and working hard, and thinking, I think I can make this happen. Dutch did it the other day. I can do this. And it's a funny thing. I had briefed everyone, reminded everyone, reviewed it with everyone, reviewed the test teams, and I'm still susceptible to the same threats. No doubt that bit us when we went out to the ship. That pilot was seeing some stuff that was unusual, difficult to interpret, and yet he still elected to continue with the approach. And our test teams saw some indications inside their control room. They were worried, but we didn't clearly communicate that on the radio. So there was some interesting stuff there. What are we walking away from? I think it's really important to build a flight test continuation game plan that has a quantifiable cross-check. So allows you to objectively assess how are we doing? Are we doing as well as I think we are? Does my, do my personal traits, that may get in the way, are they still are they still an advantage to us? Practice communication and training. Communication is not easy. It's not easy for an engineer 2 years out of school to raise his hand and say, hey, this flight test event that we've been working 14, 16 hours a day on, there's a lot of pressure to complete, and we're out here on the ship, I want you to stop everything you're doing. It's not an easy thing, but if you practice it, it makes it a more likely condition to occur. and identifying better timing. In both conditions, I think we had decent timing identified in nadir refueling, and the shipboard event, that decision should have been made well before deselling to the hover. And we didn't provide them with quantifiable tools saying, hey, if you can't identify certain aspects of the ship on the downwind, then we're not landing. We obviously did after that and restricted ourselves from conducting any more aided landings. And then acknowledge that, hey, the same things that make us good pilots can also make us bad testers. So I think that the ability and the willingness to hack it has gotten me through OCS, it's gotten me through flight school, got me qualified on the carrier the first time. No kidding, rolling in behind the back deck of a big deck carrier in a T-45, I didn't think this was going to work out well at all, you know. But I was like, I think we can do it. My buddy just did it. I've been doing it in practice. I'm going to do it now, and we made it happen. That same thing, that can come back and bite you. So I think it's good to be aware of it, and the awareness of that is perishable. It goes away. All right, I went over my time successfully. Most of us stayed awake. Are there any questions for me? Sir, in the back, and then the Commodore.
What were your escape options? I mean, if the engineers were going to call knock it off, what were the options open to the pilot? Can you turn the lights up, or can you divert to shore?
Great question. So at the point in the hover, you cannot divert to shore due to fuel state. You're committed to the ship. So yes, you can turn the lights back on. What we perceived, and that was an option. I firmly believe that what saved us here is the stability of the aircraft. So if you go hands off in that condition, it's going to maintain its relative position over the spot for you if all systems are working, and it did. He did not have a lot of options. He could turn the helmet off and ask for more lights and let his eyes adjust. And there was time to do that, but I think on stem power, that was not an option that came to mind to him. So my real thought is you've got to make that decision. We didn't rearm. You know, we pre-armed the teams, but we didn't rearm them in the brief that night to make that decision early enough. Obviously, the next night, we were fairly well triggered to do that. Commodore.
Real quick, the videos were shown in the tanking. How many different test pilots were in those videos?
I think we had everybody in the shop go across. Oh, different test pilots? 2 different ones in those videos. And then almost every pilot in the shop went across the back of the tanker.
Okay, because the Iron Maiden, like you point out, it's a very high gain task, and a technique is to move the tails like that, and your jet doesn't move. Another technique is to just not let the tails move, and the jet still doesn't move.
Yeah, that first pilot you saw was a high gain pilot. He got the award for saturating the controls more than anybody else. He also had a very Marine-like reaction at the ship. It started to shoot past the spot and just pulled the stick out of its control quadrant, trying to slow down the aircraft. So you want him on your football team, and he's also a good high gain tester.
And those points were all high altitude,
high altitude, heavy weight. So the biggest challenge is really transitioning through the turns and then finding those conditions where it's just not workable at all. Which were actually easy to find with the KC-135, not an autopilot. Sir?
probably didn't need a JSF behind that. You could have proven the same thing with the Hornet, or a similar lesson.
I think so. We were really hoping to avoid that, you know, to find a corner in the tanker like that. Again, you're getting lucky not to have anybody hurt. And we've all seen, anybody who's plugged on the Iron Maiden knows the cliffs are steep, and they generate a lot of fun stories once everybody's on deck.
Along those lines, are you putting anything in the test monitoring or on the jet to tell the pilot he's getting the rate limiting and he's saturating your control system?
Well, I think that's exactly what the control room's for. They are monitoring your control inputs and your flight control conditions. So, no.
No knock it off at all?
Yep, that's exactly. Bingo. And that's one of the major learning points from this is, man, our test team communication with the test pilot broke down.
Question. You pointed out that there was miscoordination between the pilot making a corrective action and the boom operator. Did you guys come up with some sort of enhanced communications to avoid that?
No, and this is, let me give you this could be a long answer, but the Air Force is boom operators are not going to change the way they conduct their work to satisfy a fighter pilot's input. I can tell you that from many transpacks and discussions on Wake Island. Hey guys, how about stop moving that boom? And they're like, nah, this is the way we do it. So no, I don't think that's not a battle I want to fight, because it's not going to change the way that the F-35 tanks on the 135. Does that make sense?
Let's defer any other questions until panel discussion, if we could, please. Round of applause for the technical.
Thanks for your time.
So a couple things jumped out at me during